Next one is weldments. Now, weldments has been around for a long time, and it never ceases to amaze me the amount of things that we can add to it and enhance it to cover more elaborate use case scenarios. And today is no different. So I want to show you some new visualization capabilities, some fantastic gusset enhancements, places it never would have worked before, and then some end cap creations. And then we'll move over to things like weld beads and the way the cut list now functions. So for any of you that use weldments, cut list functionality is probably one of those things that you can deal with and work with, but it's not the most user-friendly. It more or less can be a little bit distracting or difficult because of the generic naming system. We're going to cover a lot on these particular topics. So let's go right back into SOLIDWORKS. We're going to go ahead and open up this weldment. Now, the weldment that I'm looking at currently is a single part file, as all weldments are, and this single part file is based on just our basic structural library, but it's got a mix of different things. We've got some sheet metal components over here. We've got round tube and rectangular tube and plates, the basic things that you would see in a lot of welded structures. First thing I want to talk about is a little bit of the interface when it comes to the actual creation of the structural members and the groups. First of all, you can see what the groups are of the components on the screen a couple of different new ways. If you select the group, they highlight not only just the path down the middle of the components, but the actual bodies themselves highlight in yellow. You can also hover over the components on screen and you'll see what groups those components are part of. So really simple, I don't even have to scroll through it to see what groups each of these bodies happens to be a member of. So visually, that's a great improvement. Second thing I wanted to show you here actually had to do, and let's go back into that again, was a change that was made to our corner treatments. If we go ahead and take a look at this corner treatment bubble, and anywhere there's a magenta dot, not only weldments, but also in patterns or sheet metal, those are points at which you can individually action on those particular locations, which means global settings aside, you can be very refined and detailed specific to the point we're selecting. So when I select this particular corner treatment, what I want to do with this is just go ahead and show you that first of all, the trim order is listed next to the groups themselves. You don't have to scroll through and watch this box move from 1 to 2 to 3. So simple thing, but a lot of the simplistic changes to the software really have a lot of teeth because they cover annoying things or access to information, which this one does. This box also is now what we call non-modal. Before, when this box was up, my graphics would preview, but that was locked out of things like zooming and rotating. Well, now I can actually do that while I am midstream into this box. So if we want to see this a little closer, maybe we want to go ahead and change the trim order of something, for example. We change it and we see the preview right away. I go ahead and start changing this one here and changing the trim order. We'll see some pretty drastic changes to that preview as well. But I can see that either the orientation I opened this box in or in any other orientations that I choose. So that one there is quite helpful. But being non-modal is obviously the most important part to being able to interact with that without really knowing what you want to see before you actually see it. All right, let's go ahead and move over to a little bit of our gusset capabilities here. Gussets are something that obviously work in perfect scenarios, but everybody does things in a unique way, and they don't always stack up into a nice little bucket of usable use cases. When a gusset functions every time, this is the type of situation you'd see it in. So let me start with that. Grab your gusset tool off your Weldment's toolbar and select a couple of adjacent faces. Preview shows up where you can then go ahead and determine the thickness based on left, right, or midplane. Also, orientation can be left, right, or midplane of those faces. So nothing really new to those. Let's make this significantly larger, though. Okay, that looks pretty good. Say OK to that, and of course it's going to create that piece of plate gusset right there between those two faces. Other cases, though, are ones where we've really had some difficulty with in the past, and they have to do a lot more with non-planar faces. Obviously geometry that's not either coming to a virtual intersection or having a nice concise intersection point defined. Well, these cases are now available in SOLIDWORKS 2015. So we'll use our gusset first of all to go ahead and select a couple of round parts. So now in this tube steel, it's going to build a gusset that's going to be tangent to that round face. These arrows that show up allow you to actually switch the sides, which of course doesn't make any sense in this case, but it does allow you for some orientation control. We'll do gusset again, this time between a flat face and a round face. Now, there's no preview initially on this. The reason being is because it doesn't really know the orientation between these. It could be above, it could be below, and frankly, this face could be infinite in all directions, so it could be almost anywhere. So down here you have a location capability that gives you the option to choose an edge, and that edge will act as a vector. So if I grab any edge going in the proper direction of my rectangular pipe, we'll see that that gusset is inserted properly, just as if it did between these two circular tubes. That one also can be flipped to the bottom side. There was the same type of arrow on that. Probably should have showed you that. This one does make sense. So flip it to one side, flip it to the other. So all those things work really nice. Now, believe it or not, this is probably one of the most common use cases. You've got a plate that you've added to a welded frame, and this is one of the ones that really had trouble with. And the reason is because it's not a square plate and a rectangular tube coming together. It's a square plate and a rectangular tube with radiused edges. Therefore, the virtual intersection between these two actually goes into that corner. It's a really interesting situation. Well, this is now very, very expectable in the way it works. Sorry, I made up a word there, but this is a simple thing. You go ahead and select a couple of faces, and just like the two rectangular tubes prior, it builds the proper adjacent gusset between those two faces. It's now extending this face to the virtual intersection in the plate. Now, those types of use cases for gussets were also challenges for our weld tool. The weld tool has started changing in a very, very positive way back around SOLIDWORKS 2010, where we switched from the fillet weld to the weld bead function. And the weld bead is more of a virtual weld. Virtual meaning it doesn't physically create solid geometry, but you do get feedback for the length of weld, potentially the weight and cost of that weld, and then the auto weld symbols for those as well. But it works in much more odd places because it doesn't create solid geometry, therefore it doesn't need the perfect setup to create a sweep or adjacent geometry lofting or things like that. So here we're going to use the weld bead in some of these new cases. The basic way we would use the weld bead would really be to select components and group them together. So as I select my gusset and I select my two pieces of circular tube, we're going to see the virtual intersection that's generated between those. Once we define the proper radius of this, we don't have to exit this tool if we want to continue to make additional weld beads with the same settings. What we do here is we go ahead and say new weld path, just like we would say a new group creating our structural steel. So new weld path will allow me to go ahead and select other situations. So over here's another one that was a little bit more of a challenge, user interface wise before, was the selection between this part here and this part here. Now these have kind of a stitch in the way that they intermittently touch, but it actually creates three individual weld paths where the three individual weld paths show up between these two selections. So single selection, but a lot more output with a minimal amount of input. Let's go ahead and do another new weld path. Up here we have two situations which were quite a challenge before as well. We've always, even with the fillet weld bead, had some capabilities to weld one part to another, but we've never had good capabilities of welding a part to itself. Here with a sheet metal part, we would fold that up, we'd weld those corners, probably hit it with an angle grinder or a belt sander and shave those right down, and they'd never exist. But we still have to represent the weld bead here in our CAD model. So the way we do this with our weld geometry, our original settings here, is we'd select a face on this side, and then I'd go ahead and select, say over on this part, we'd select an edge. And what that edge is going to do is give us the virtual intersection between those areas. So where this face and this edge come together in 3D space. Let's do one more new weld path, and this happens to be another one of those use cases. We have a rolled piece of sheet metal, which is again going to be welded back to itself. Well, here we actually can't use the weld geometry because we're only going to do a single selection. So we have a new radio button option that was added to the software called Weld Path. By simply selecting any edge of this vertical face, we're going to get a weld the complete length, and you can even do intermittent or stitched welds based on that edge selection. When we go back over another new weld path here to this situation, our common plate and our common structural steel, this gusset is very easy, but the weld on this gets to be extremely complex because it's not just a straight face. There's this fall off, or this radius goes away from this face. So here's again where we use the weld path option. All I do is select edges, and those edges are all we need to put this in. In fact, I could sketch something with a spline or a circle and use that as a weld path as well. So if you want the welder to weld your name to a part, grab the spline tool and try and write your name in cursive. Basically, that's all it takes, is any physical edge of solid geometry or even sketch geometry to make these. Once we accept them, we get this nifty looking weld bead out there. It's going to show up in all of those corners. We see that over here as well. And then as well as that, we got our sheet metal parts that are welded to each other at the corners. So great enhancements to the usability of that tool. I want to show you a little bit now about some end caps, just real quickly here, and then I want to talk about the cutlass folder. It's probably my favorite part of this. End caps are nothing new to gussets, but recessed end caps are what is new now, and you can see one over here to the left. End caps have always been very simple. Select the tool, grab the face, and it automatically creates an end cap about the size of that face. There is a little bit of an offset ratio that we have when it comes to the size. But other than that, we can do things like adding corner treatments, where if I want to chamfer those corners or fillet those corners, we can ramp that up a little bit. But I can change this from an end cap, which is actually outward, to an end cap that is inward. We've had those before, flush to the outside face, but this is now a recessed one we call internal. Internal allows you to push that value back into the part as well. You can see it moving into the part. And I'm just going to put that in there 10 millimeters with a really, really minor offset here, because I want you to see what this looks like. When we say OK to this, what I found most interesting here is that we don't create an end cap that's actually going to take 3-axis CNC to create. Somebody was thinking about this. We make an end cap, and even though it's perpendicular to the end face and not perpendicular to the actual body because of the angled cut, we create an end cap which is actually perpendicular geometry so that it can be simply lasered out or single end milled out and then placed in and held and welded. We're not making a bevel on this face to make the end cap one of the more complex parts of this assembly. So good forward thinking by the developers in that case. So let's look over here to the left-hand side, to our cut list. There's 2 things that we do for performance over here. One is I can right-click on this weld folder and actually suspend automatic rebuilds. Therefore, performance-wise, if I was to change the size of this assembly, those weld beads wouldn't necessarily update real time because that's a performance hit. You probably saw that it took a few seconds to generate those. You can click rebuild and then that will bring that up. But on the weld cut list itself, these are some things that I find significant. First of all, I've added some gussets and an end cap, and you see that these are at the bottom of my tree. Well, for anybody that's used this tool, I think that everybody assumes that there's an automatic update tool. In fact, I was of the exact same assumption. When you right-click the cut list tool in 2014, you would actually see a choice that said automatic. Now that automatic, unfortunately, was automatic grouping, though they didn't give us really proper terminology from the user interface from the developers. So I really thought that that was an automatic update as well. Well, now you see very clearly that there is a tool called automatic update or update automatically. By clicking this, I'll never have to readdress this cut list again. Those 4 gussets at the bottom and the 1 end cap will jump into folders that match other geometry sizes. But if I add additional things, those will also automatically jump into these folders. So that's the first most important thing there. There are a lot of Weldment settings that are actually under Tools and Options. So this is file specific. We'll go to Document Properties, and then under the Weldments tab. Now what I've just done is I've actually turned this check mark on by the right click I did in the cut list folder. So automatically update the cut list. But one of the most important ones now in this release is this one that says rename the cut list folders with the description property. Because to me, cut list item 32, 38, 40, this means nothing. You have to interrogate it to figure out what it is. But if you click on rename and say OK, watch this. Those are much more appropriate, I believe. It's going to give you the size of the material, so it's giving us in this case the description of the profile that we used for the square or rectangular tubes, the plates that are in there for the foot pads, the plates for this plate, other plates here, even the gusset information. Well, gusset information is kind of interesting. It doesn't have descriptions of each of these. And in previous releases, this is something that's not new, but I'm going to go into properties and just show you this. If we look at any of the other plates, the plates automatically have these bounding boxes around them that give them length, width, and height and thickness. But these new ones that I've added, they only have material and quantity. So in SOLIDWORKS 2013, what we added was an operation where you could right-click the cut list and say, Create Bounding Box. So watch cut list item 55 and 56 when I say Create Bounding Box. They rename with the description property, because what's happened is as we go into the properties, the bounding box has automatically detected the thickness, width, length, and volume and given us an associative property as well as a description using each one of those little property names. So we have this fantastic associative thing where if I change the thickness or I change the angle, 125 is the one length of my gussets, then you're going to see that that's going to update dynamically for you. So some really great user interface features which use better naming and automatic updating of things in the Weldment cut list. You also can right-click and save this assembly. So if you do want to save this out as an assembly, you can click Save Bodies. And this new functionality actually allows us to go ahead and take multiple parts of the same size and create a single part file, quantity of 4 in the resulting assembly. Prior to that, every single body was exported as an individual part file, but now this derives similar parts from, derive resulting parts from similar bodies or cut lists. will take any identical components, export them only one time, and then build an assembly with the proper quantity of those. So that's the most important part there. So lots of great things with weldments. Cut list interaction and on-screen interaction definitely top the list of those.